Hi, this is Dr. MSNA Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, I am going to discussing about electrochemical cell construction, working, and applications. Electrochemical cell is also known as galvanic cell. That is a cell which can convert chemical energy into electrical energy through a oxidation and reduction reactions. Galvanic cells are electrochemical cells in which the electrons transfer due to redox reaction. Here, what is redox reaction? So, in a cell, simultaneously oxidation and reduction reactions takes place. That is known as redox reactions. Through this redox reaction, electrochemical cell can convert chemical energy into electrical energy. That means both oxidation and reductions simultaneously takes place in electrochemical cell. Next, coming to the example. So, what is the example for electrochemical cell? So, well-known example for electrochemical cell is Daniel cell. Let us see the construction of Daniel cell. The galvanic cell or electrochemical cell made up of two half cells. Here we can see the two half cells. One of the half cell act as a anodic compartment and another half cell act as a cathodic compartment. In anodic compartment, oxidation reaction takes place. In cathodic compartment, reduction reaction takes place. These two half cells are externally connected with a wire and internally connected with U-shaped tube, which is known as salt bridge. Salt bridge contains saturated solution of KCl. Let's coming to the first half cell, that is anodic compartment, which contains zinc electrode, which is dipped in ZnSO4 solution. And the second half cell is made up of a copper electrode, which is dipped in copper sulfate solution. Both half cells are connected externally by metallic conductor, that is conducting wire, and internally connected by a bent glass tube, which is having saturated solution of strong electrolyte KCl. It is called as salt bridge. It acts as a bridge between the two half cells. And main function of salt bridge is to neutralize the both half cells during reactions. So, salt bridge or porous barrier maintains electrical neutrality by allowing ion flow between the two half cells. Let us see the reactions takes place in electrochemical cells. At anode, here zinc, that is the anodic compartment, there oxidation reaction takes place. In electrochemical cell or Daniel cell, what is the anode? Zinc acts as a anode and copper acts as a cathode. Oxidation takes place by the liberation of two electrons from zinc. So, metal zinc converted into metallionic zinc at anode by the use of electrons. If the reactions oxidation, in which electrons are released, that is oxidation reaction. So that's why we can say that at anode oxidation reaction takes place and their electrons are released. And next coming to the cathode. Here cathodic compartment contains copper electrode which is dipped in copper sulfate solution. There copper acts as a cathode. That means reduction takes place at cathode. Here gain of electrons takes place at cathode. Cu plus 2 ions convert into metallic Cu by the gain of electrons. Next coming to the overall reaction, Zn plus Cu plus 2 gives rise to Cu plus 2 and metallic copper. The EMF of the galvanic cell is 1.1 volts. That is about reactions of galvanic cell or Daniell cell. So we can represent the galvanic cell or Daniell cell as below. So zinc slash ZnSO4. That means zinc electrode dipped in their corresponding salt, that is ZnSO4. And next, these two bars indicates salt wedge. Salt wedge is placed in between the two compartments. Here, this compartment acts as a anodic compartment and this compartment acts as a cathodic compartment. So these two compartments are separate to each other by salt wedge. At cathode, copper which is dipped in their corresponding salt, that is copper sulfate solution. So this is the cell representation of Daniell cell. Next coming to the applications of electrochemical cells, where we are using electrochemical cells. At batteries and power sources. So usually we are using electrochemical cells in batteries. Here electrochemical cells are the basis for batteries like alkaline batteries, lithium-ion batteries, lead-acid batteries, nickel-cadmium batteries, etc. zinc-air batteries, and they provide portable electrical energy for devices like phones, laptops, cars, and flashlights. And next application is electroplating. Here, electrolytic cells are used to coat a metal object with a thin layer of another metal. So that is known as electroplating. So electroplating is one of the corrosion protective method. Here, one metal is coated with another metal. That coating process is known as electroplating. Here, electrolytic cells we are using to coat whatever metal protected from corrosion. So that is known as electroplating process. Here, silver, gold, and chromium to improve appearance and corrosion resistance or wear resistance. So we can increase the properties of corrosion resistance as well as wear resistance by applying electroplating process. Next, electrolysis. In electrolysis also we will use electrochemical cells, different types of electrochemical cells. Here, usually in electrolysis process, electrochemical cells are used to decompose chemical compounds. For example, water into hydrogen and oxygen gas. So with the help of electrochemical cell, we can decompose or convert water into hydrogen and oxygen gas. And some industrial production of chemicals such as chlorine, sodium hydroxide, and aluminum. There also we will use electrochemical cells of different types. Next, corrosion protection. Here, corrosion protection is nothing but protection of different metals from destruction by the attack of foreign substances. So that is known as corrosion. So by using electrochemical cells, we can protect the different types of metals from corrosion process, especially cathodic protection. Here, what is cathodic protection? So we can protect the different types of metals from corrosion process by cathodic protection. So here, whatever metal we are going to protect it from corrosion, that metal make into cathode. So applying an electrical current to metal structure like pipelines and ship as to prevent the corrosion process. So this is the best example for cathodic protection methods. There also we will use electrochemical cell principle or construction. Next, different fuel cells. We will use electrochemical cells in different fuel cells to convert chemical energy directly into electrical energy by reacting hydrogen and oxygen, which are used for clean energy applications. Next applications, sensor and analytical devices. Like electrochemical sensors like glucose sensors detect specific substances based on redox reactions. So here also we will use electrochemical cells. Next important application of electrochemical cells are metal extraction and refining. Number of electrochemical cells help in extracting metals from ores and purifying metals like copper and aluminum. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.